Hey guys, welcome back from fall break. I hope you had a safe, happy, and healthy fall break, and we're glad to see you back to learn some more statistics with us today. All right, so we're going to talk about testing a difference in proportions. That's what we were learning before the break, and we're going to apply it to other contexts other than sports. So, just kind of a fun example. I read this article about how women have a greater ability or have a better verbal memory function than men. So we're kind of thinking about, do girls actually have a greater ability to memorize short sequences than boys? So what we're going to do in class here, so if you're at home watching this, I would suggest just giving this a try and timing yourself and kind of seeing what's going on here. But the more important part is I wanted you to see the simulating with technology piece of it, because that's what you're going to need for your investigation. So our question of interest states, do girls have a greater ability to memorize than boys? So that's our question of interest. And if we were to be having a difficult time with using that greater ability or same ability, another kind of non-sports related term for your null and your alternative hypothesis is when you talk about someone having an equally likely opinion or a greater opinion in one scenario. So still just remember that null hypothesis states that the individual are going to have the same ability. So girls have the same ability to memorize. I don't know why I put an H on the end of that. To memorize short sequences as boys. And for our alternative hypothesis, that's our statement of change. So we'll state that the girls have a greater ability to memorize short sequences than boys. So this is an example of an experiment because we're going to actually be taking the boys and the girls, which are our subjects, and we're going to be testing by asking you to take 15 seconds to look at the words posted on the board or posted on the next slide. And then from there, wait for 30 seconds, kind of let your memory fade off for 30 seconds, and then for another 30 seconds, write down as many words as you can remember without looking at the board. And so we're going to create this two-way table here and overall compare our percentages of the more than 10 words, because we're trying to see if girls have a higher percentage here than the boys. So just an example, here's some words. You're going to do it a second time. So we're going to see if we change some of the variables that we originally were controlling, if that changes the outcome of our experiment. But ultimately, you're going to create a dot plot and calculate the p-value from your dot plot. So I wanted to show you the stat applet that we use. So it looks like this. It's a difference in proportions. What you have is the successes. So that would be how many girls memorize more than 10 words, and the successes for the boys would be how many boys memorize more than 10 words. Or like if we're talking about winning games, success, how many wins were at home, how many wins were away. Context 1 and context 2 depend on your alternative hypothesis. So if context 1 states, or if it states that that girls have a greater ability to memorize words than boys, girls is context 1 and boys is context 2. If we have a greater ability to win games at home than on the road, home is context 1 and road is context 2. So you type in the number of successes there. Let's say that the girls memorized, 10 girls out of 15 total in the class memorized 10 words or more. And then let's say only 3 boys, memorized out of 18 boys. So obviously that percentage is going to be lower. When I press calculate the observed difference in proportion, you'll notice that it gives me a test statistic. The observed difference is your test statistic that you're seeing if you can simulate multiple times, again, by random chance. From there, we want to simulate 100 differences, which means I'm going to have 100 dots on my dot plot. And it's going to give me the simulated difference in proportions. So my observed difference is 0.5, which is 50%, but I'm looking for 0.5 on the graph. So from here, this is your dot plot. You can take a screenshot, there we go. A screenshot of the dot plot, put that into your project. You can also write it by hand and put it into your project, but then you have to create 100 dots, which would be really annoying. But ultimately, this is going to be the results that you're going to compare the p-value for. So I would find where 0.5 is on my dot plot, and 0.5 isn't even on this dot plot. It's off of the dot plot, giving me this hugely convincing evidence that there is, in fact, a greater ability for girls to memorize short sequences than boys. So what I want you to do for today is kind of think about some of the questions that come with this. Did the timing affect the amount of words that you can memorize? If I gave you 60 seconds, would you be able to memorize more? What are some other variables that you think could affect the experiment? So is it the kids that are sitting closer? Are they more likely to memorize more words than kids who are sitting further away from the board? Or if you have a kid whose phone vibrates and they get that instant distraction, does that take away from you memorizing the words? So there's just some things that you want to consider. And what we're going to do is start working on our project. So if you're working on your investigation, just start thinking about who you're trying to investigate and what the context is behind your investigation project. So I hope you had a great fall break. We're happy to see you back and start learning again. Let us know if you have any questions.